Team. Assalamu alaikum. Welcome to LabVIEW Core 1 training. This is part 3 of lesson 5, creating and leveraging data structures. Please make sure you have watched all the previous parts before watching this third part of lesson 5. In this part we are going to discuss auto indexing. So objective is to use auto index inputs and outputs to create graphs and arrays. Topics covered will be use in for loops and while loops, waveform graph, auto-indexing with a conditional terminal, creating 2D arrays, and auto-indexing input to a loop. Alright, so what is auto-indexing? It is basically the ability to automatically process every element in an array. Alright, so here you see that auto-indexing is enabled in for loop. So you can right click the tunnel and select enable indexing or disable indexing to toggle the state of the tunnel. At this time, this tunnel is in auto indexing enabled. Auto indexed output, like in this case, results arrays. And arrays are always equal in size to the number of iterations. So this array size will be of the same size is equal to number of iterations this loop runs. Say suppose this loop runs for 6 iterations, though the array size will be 0 to 5. Range will be from 0 to 5, it will consist of 6 elements. And third thing, that only one value, last iteration is passed out of the loop when auto indexing is disabled. In this case, you see that auto indexing is disabled and only one value, that is basically last iteration, is passed out of the loop. You see wire remains the same. This wire does not show, clearly shows that it's not an array, it's only the last value is passed. But here you see the wire shows that array is coming. Alright. Alright. So for loops and while loops can index and accumulate arrays at their boundaries. This is known as auto-indexing. The indexing point on the boundary is called tunnel. This is tunnel. The default behavior for loop is that auto-indexing is enabled. But in the while loop, default is that auto-indexing is disabled. You see in for loop, auto-indexing is enabled. Whereas here, the default behavior is auto-indexing is disabled. Only one value, the last iteration, is passed out of the while loop by default. Alright. So how can we enable and disable? I again repeat, you can right click the tunnel and then enable auto indexing to collect the values within loop and build the array. And also you can disable auto indexing. If enabled auto indexing is there, then all values are placed in the array upon exiting the loop. You can disable auto indexing if you are interested only in the final value. Alright, so let us move ahead and discuss waveform graphs. A waveform graph collects the data in an array and then plots the data on the graph. So always remember, waveform graph collects the data in form of array and then plot the data. In this case, you see sine wave data is coming, cosine data is coming. This is a for loop. By default, auto indexing is enabled, and you want to see both plots on the same waveform graph. Therefore, you need to use build array function. So here you see a sine wave and a cosine wave on the same waveform graph. Remember in exercise 4.3 of the lesson 4, you stated that if you want to plot more than one data set, more than one plot on the waveform chart, then for that purpose you use build function. But please remember, when you want to see multiple plots on the same waveform graph, as the waveform graph accepts the data of array, therefore you must use build array in order to see multiple plots on the same waveform graph. Okay, charts versus graphs. We are going to give this slide a significant importance because being engineer, we have to mostly deal with results of different experiments, of different research work, and we mostly deal with these charts and graphs. We observe the results here. So we must be expert in order to understand where to use chart, where to use graph, how to use them properly in order to accumulate results of your application and need. So we are going to spend a little time on this discussion of comparison versus charts and graphs. Basically, charts are generally used inside the loop, inside the while loop, or inside the for loop, and graphs are generally used outside the loop, outside the while loop, or outside the for loop. Say, suppose in this case, you see, you are using this waveform chart inside the loop. This is the first main difference, and you are using this waveform graph outside the loop. Why do we do this? Let us go into detail. All right. Okay. Please select one new VI, open one new VI, and then let us perform temperature conversion from Fahrenheit to centigrade and then use waveform graph and chart in this application, and then continue our discussion to differentiate between a waveform chart and waveform graph. Pick a while loop. All right. And then you know that you know that this is a formula of conversion from Fahrenheit to centigrade. So you need to have a function that should be 5 divided by 9 and then multiplying it with Fahrenheit given point minus 32. So do it. Go and take one division function, create constant here of 5, create another constant of 9, and then go to front panel, take one, this is your Fahrenheit value, and then Fahrenheit value should be done minus with 32, create constant 32. Alright, then multiply these together. So in result you will get now here your Celsius temperature. So label this while loop, right click, subdiagram label. This is conversion of Fahrenheit into what? Into Celsius. Alright. Pick up a waveform chart. This is the waveform chart. You are going to observe this result on waveform chart. Also create a numeric indicator, name it Celsius. And same data should also go to observe the result on waveform chart as well. Name it Celsius chart. Alright. Now let us run it. You know that 32 Fahrenheit is equal to 0 Celsius. You see, 32 Fahrenheit is equal to 0 Celsius. Create control for this condition terminal. Alright. And run it. You see 0. 32 Fahrenheit is equal to 0. And if I enter 98 Fahrenheit, this is equal to 36.667. So let us enter 98 Fahrenheit. This is now 36.667, and you can also have the result on the waveform chart. Alright. Create the stop button. Okay. So what we observe on the waveform chart. Now let us observe the results on the waveform chart and start our discussion on waveform charts. See, you can also clear this waveform chart by going data operation and clear chart. Okay. I am inserting a wait millisecond function here to observe results with a little delay for 100 millisecond. Okay. Let us make this Fahrenheit 32. Now you see that last 100 values point by point that are sent over to waveform chart. So if it is 32, result is 0. If I make it 98, result will be 36.667. You can see the result on the chart. So charts are good for visualizing data point by point over time. So you are observing the data point by point over the uh, chart by time. Okay, when you click stop, now you see you have observed the results on this chart, and you can also see from 0 to 337 all the graph together. You see, so it retains the history. Waveform chart has this capability that it can retain the history and then show you all the values that it has stored in that waveform chart. So simply you can say that waveform charts are good when you want to observe point by point data that are sent over to waveform charts. So charts are good for visualizing data point by point over time. But if you want to visualize entire data set all at once, that's where we should use waveform graphs. So you do not want to see point by point, but you want to see entire data. I mean array. There comes the application of waveform graph. There you would prefer to use waveform graph. So pick a waveform graph here, name it Celsius graph, pick up here, connect the output here as well. Now you see you cannot connect it because because graph accepts array, data of array, but it is a single point. So here the problem. You cannot connect this directly here because default behavior of the while loop is that auto indexing is disabled, and if auto indexing is disabled only the last value is passed, but here waveform graph expects array to be accepted. Therefore click this but tunnel mode and enable the auto indexing, and here now it gets array. All right, so now clear this chart and then set this Fahrenheit to 32 and then compare the results on this waveform chart and waveform graph, and then compare their behavior, their response. First it is 32 centigrade, it's showing 0, but you see waveform graph is not showing the results. Let's make it 98. Now it will be 36.667. Let's make it again let's make it again 32, and then let's make it again 98. So you are performing conversion from Fahrenheit to Celsius, but the result on the waveform chart are not available. Results on waveform chart makes only available when loop ends. Only then data becomes available on the waveform graph. See, if I click the start button, now only then the data is available on this waveform, basically graph. Alright. So now you can also change this axis from 0 to 350, and this is also from 0 to 350. You can see the results are similar on both waveform chart and waveform graph, but the difference observed was that data became available to waveform graph only when loop ends. Only then data becomes available on the waveform graph, but here waveform chart is used to observe data point by point, and here the results becomes available only when the loop ends. So I want to conclude that chart shows point by point data, whereas graph is used to view a certain data set all at once. Alright, okay. Now I hope that you are clear about the difference between a waveform chart and a waveform graph. So let us discuss some additional functionalities, properties of this waveform graph and waveform chart. So there's the one function which is called chart history length. Now you see I can see data set, I can see history length from 0 to 350 L as well in this case. Okay, and at a time I am observing 100, I am observing at a time 100. You can see if I click auto scale at a time I am observing, if I uh, clear this chart at a time, you are observing these results data by point on this waveform chart. All right, so you can also change its chart history length. For now it is 1024. If you make it 50, then you can only observe 50, 50 data points in chart history buffer. See, run it, you can only observe up to 50 data points in the chart history buffer. After that, other values cannot be stored. If you run it up to 100, let us say, and you click the stop button, then you see only results will be available up to 50 data point. Now first 50 are removed because it can only store only and only 50 data points. So therefore, if you want to see more data points in a chart history buffer, then you should increase this buffer size, chart history length. All right. Okay. Now let us discuss another feature which is called scale legend. Go to right click, go to scale legend. Now this is basically scale legend. Here with scale legend, you can change the labeling of x-axis and y-axis. Say suppose you are labeling anything, you see you can change the labeling using this scale legend. All right. Let's make it amplitude. All right. Okay. This button is for enabling the auto scale x-axis function. Now you see at this time, say suppose auto indexing is not enabled. So at a time you are observing 100 data points. This is the default behavior of the waveform chart. But if you want to enable auto indexing, when this lock is unlocked, this means auto indexing is not enabled. And when you lock this, you will get auto indexing enabled. You see, auto scale x is enabled. So using this lock, you can either disable the auto scale x, or you can enable the auto scale x. So this is a function of this auto scale future. So using the operating tool to click the scale lock button shown as follows to toggle auto scaling for each scale. So this is the work of this scale lock. Okay. Other is the auto scale button. This button. This will shown as follows to adjust the scale to reflect the data you wire to the graph or chart. Say suppose at this time you disable the auto scale X and you want to see auto scaling for a few seconds. You can enable it. When you click it, auto scaling will be. When you hold it, auto scaling will be enabled. When you leave it, then again auto scaling will be removed. And third, this function is called scale format button. This shows how to configure the format, precision and mapping mode, set the visibility of the scale and scale label, and specify the grid color. See here, like you can change the format, you can change the precision of X scale, Y scale. You can also change the grid color. Let us see. This is how you change the grid colors. You see, background of the grid is changing. So this is a function of this button. All right. Okay. Now let us discuss another important tool which is a visible item, that is graph palette. You see, graph palette has three options. So this is basically a graph palette. It has zoom capability, cursor movement tool and planning tool. Let us discuss first zoom feature. When you click zoom button, you see that there are 6 choices available. First choice is this one. This can zoom by drawing rectangle on the plot. See, you draw the rectangle and that rectangle portion is zoomed. So this is a function of this uh, zoom by drawing rectangle on the plot. The second one, this has the function of zoom only the x-axis. You can zoom only x-axis. You see, x-axis are zoomed. Alright. This one, third function, can zoom only the y-axis. You see, y-axis can be zoomed. Y-axis can be zoomed. This fourth function, undo zoom and show full scale of the plot. You see, full scale of the plot is shown. This can undo the zoom. Alright, and show the full scale of the plot. Fifth one, these two are used for zoom in and zoom out by clicking and holding the cursor on the plot. Say suppose you want to zoom in. You can hold it, press it and zoom in. And if you want to zoom out, then similarly you can zoom out by clicking and holding the cursor on the plot. Let us undo. This is all about the graph palette using the zoom function. Similarly, this scroll window hand allows you to move the plot just by dragging the cursor. You see, you can move the plot here and there, here and there. You can move the plot. So it allows you to move the plot just by dragging. Alright. Okay, and this cursor function is the last function that moves the cursor on the display. If you click it, you see you can move the cursor, you can move the waveform chart on the display using this cursor button. Alright. Okay. Waveform chart and waveform graph has some similarities. These both functions are also available in scale legend and graph palette in waveform graph as well. One thing more I want to discuss, that you can also change the look of this waveform chart from this common plots. You see, you can change its look, designing. You see, you can select any of your own choice. You can also change the color. You can make color of your own choice. You can also change the line style of your own choice. You can also vary the line width. And some other more functions as well. And you can also export the data if you want to see this result on your Microsoft Office file. Then go to export and then export data to clipboard. Sorry, first you stop it and then right click it, go to export simplified image, and then this meta file, and then hide grid, and then click export, and then after opening your this Word file, you can simply paste it to see the result on this Microsoft Office, and you see pixels are very high quality pixels. All right. Okay. Okay. Now we are discussing one important feature of this waveform graph. In waveform graph, there is an additional feature available, cursor legend. This is the cursor legend. This is very important, high importance in our field of electrical engineering or any engineering field where you want to uh, perfectly measure the exact value of cursor X position or Y position. You use this cursor legend. So let us use this cursor legend. For this, I create a new VI and I simply create a for loop and I run it for 100 iterations. I am taking a random number that generates data between 0 and 1 and I display it on a waveform graph. Alright. Now data can be displayed on this waveform graph. When I click run button, you see this 100 iterations. For 100 iterations, you can see the data for of this random number on this waveform graph. Alright. Now let us use this function of cursor legend here. You can also drag it and put it beneath the waveform graph. Alright. Okay. Now let us create a, now there are three options that you can create a free scale, a single plot or multiple plot. Let us create free cursor first. So we create a free cursor and let us name it say suppose free cursor 1. You can name as per your need and let us make it little larger. All right. So this is a free cursor that you created and now you can use them to vary the position of Y scale. Now you see as I use this button, it moves the Y scale towards upside and it shows the position right now. It is, you can see the position is close to 0.4. You can also change its color. Go to attributes. Let's make this color red so that it become more visible. Now you see Y scale position is up to 0.4 and you can observe exactly the result. Let us say you want to see this position, what is this value, particularly this one, this point. You can measure exact value, say suppose 0.76. So sometimes you want to know the exact point of value in some research or in some experiments. You can use this cursor function future cursor legend. So similarly, you can also change x-axis position. You see now x-axis position is moved. Say suppose I want to see this position now. This is exactly 15. 15 is this position. Similarly, you can move here and there, and you can also press this line and move with the mouse as well. You see this function is also available. Similarly, you can drag it and move here and there. You can also activate create another cursor, means at a time you can create more than one free cursor as well. Let's name it free cursor 2, and you can also use both cursors at a time as well. You see now I am using both cursors at a time. Let us change its color to blue. Or you can use Y scale both cursors together. Similarly, or any individual cursor. So you can also use both free cursors together as well. So this is to know the exact point of value in any application. Or you can also use create cursor that is single plot. So this is say suppose single plot cursor. Now let us activate the single plot cursor. Let's change its color to green. Now you see you see sorry for little inconvenience. So you see in this single plot, when you create single plot look, then cursor is following plot of random numbers generated. You see it's showing plot of random numbers generated. So this is its behavior. It's resembling with the free cursor behavior, but you see in this case, cursor is following plot of random numbers. Alright. You can also show the name of the cursor on the waveform graph by right clicking, going to attribute and then show name. If you click show name, then the name of the cursor will be also shown. Alright. Let us move ahead. We had a good discussion on different usage of waveform chart, graph, and the difference between waveform chart and graph, let us move ahead and discuss auto indexing with a conditional tunnel. Okay, you can determine what values LabVIEW wires to the loop output tunnel based on condition you specify. For example, in this case, you say that auto indexing with a conditional tunnel is activated. Here you see that the array input array contains the following elements 7203195 Because of the conditional tunnel, the value less than 5 array, value less than 5 array contains this array will only contain the values less than 5 at the output. So the only elements you will see at the output will be 2031 because the numbers that will be greater than 5 will be discarded because of this conditional tunnel activated on auto indexing terminal. So you can activate it by right clicking the loop output tunnel and selecting tunnel mode and then conditional from the shortcut menu. All right. Okay, let's move ahead. Creating a two-dimensional array. Using two for loops nested one inside the other to create 2D array. Here inner loop creates columns whereas outer loop create column elements into rows. So you can create 2D array with this two-dimensional arrays using this nested loops. Auto-indexing input. Use auto-indexing input array to perform calculations on each element in an array. If you wire an array to an auto-indexing tunnel on a for loop, you do not need to wire the count and terminal. Say suppose in this case, what you observe that this count and terminal is not wired and here array is connected. So the for loop executes the number of times equal to number of elements in this array. If there are 15 element array, so this loop will run up to 15 iterations. As the iteration starts from 0, so it will show 14 number here at the iteration output. So this is one feature of the uh, for loop as well, that if you do not wire this end terminal but your array is auto indexing is enabled, then even then your for loop can execute up to the element array size this array consists of. All right, auto indexing input different array sizes. If the iteration count terminal is wired and arrays of different sizes are wired to auto-indexed tunnels, the actual number of iterations becomes the smallest of the choices. Now here are three choices. This n is also wired up to 10 iterations. This is an array of 15 element array. This is an array of 5 element array. So this loop will execute actually smallest of the choices. Smallest of the choices is 5 element array. And as you know that iteration is 0 based, so the output will show here, iteration terminal will show here 4, showing that this for loop will run for 5 iterations. And iteration is 0 based, therefore it will show here 4. Alright, okay. So now we will discuss this exercise 5.1 in our part 4 of lesson 5. Thank you very much.